In this class, now I explain you two sets of formulas of inverse trigonometric functions. Now see the first set. Sin inverse of x. Okay, express sin inverse of x in terms of cos and in terms of tan. See, to express in terms of cos and tan, now I would like to consider this one is equal to some theta. Okay, then x will be how much when you transfer sin inverse to the right side? It will come as sin theta. Now, okay, draw one right angle triangle. So consider here theta. Here sin theta is equal to x given here nothing is there means 1. You know sin theta opposite by hypotenuse. Here opposite is x, hypotenuse is 1. Now let us name the name of the triangle is ABC. Now apply the Pythagoras theorem. Okay, so that you will get BC length. Now BC square is equal to AC square minus AB square. Now which is equivalent to 1 minus x square. Transfer square to the right side so that you will get BC is equal to 1 minus x square. So BC length is square root of 1 minus x square. Okay. Now suppose if you want the sin inverse of x in terms of cos. So from this right angle triangle, define cos theta. So now with respect to theta, this is opposite, this is hypotenuse. Cos theta is equal to adjacent by hypotenuse. So square root of 1 minus x square by 1. When you transfer cos to the right side, so that you will get cos inverse of root of 1 minus x square. Okay. So students, see here sin inverse of x equal to what you got? See, we assumed sin inverse of x equal to theta, then theta finally you got cos inverse of root of 1 minus x square. So this is equivalent to this. Okay, so here write like this: sin inverse of x is equal to cos inverse of x square root of 1 minus x square. If you know the domain of sin inverse of x, minus 1 to 1, but this is equivalent to this if x is including 0 to 1. Okay, so x is lying between close interval of 0 to 1, then sin inverse of x can be written as cos inverse of root of 1 minus x square. Okay, suppose domain of sin inverse of x, minus 1 to 1 no, but here 0 to 1 I wrote. So suppose if x is negative, okay, so suppose if it is negative, as sin inverse of minus x is equal to minus sin inverse of x. Okay, as per this identity. So suppose if x is negative, the sin inverse of x can be written as same like previous one, minus cos inverse of root of 1 minus x square if x value is minus 1 to 0. Okay, no confusion here. Sin inverse of x I expressed in terms of cos inverse. So you got this is equivalent to this, you have learnt here. Suppose x may be negative also, no? So from minus 1 to 0. So in this case, so sin inverse of x can be written as minus cos inverse of root of 1 minus x square. Observe that. Okay? Right. So suppose if you want this cos sin inverse of x in terms of tan, then what do you do? In terms of tan. So go to this right angle triangle and define tan theta. Now tan theta is equal to opposite by adjacent. Now x by root of 1 minus x square. Okay. Now, okay, here we people require a theta, no? So transfer this tan theta to the right side so that you will get theta is equal to tan inverse of x by root of 1 minus x square. Okay, students, here x belongs to close interval of -1 to 1, no? So here, if x is equal to 1, if x is equal to -1, this denominator is becoming 0. So some real number by 0 is not defined. Hence, here x should not be 1 and x should not be, okay, -1. Okay. So here, theta is nothing but sine inverse, no? Therefore, sine inverse of x can be written as tan inverse of x by root of 1 minus x square, where x belongs to open interval of -1 to 1. Here, domain of x, domain of sine inverse of x. X will take -1 to 1, no? But here -1 and 1 are not allowed, because if you take x equal to 1 and -1, this denominator is getting 0. So some number by 0 not defined. Hence, x should be more than -1, less than 1. Okay. So now we have expressed sine inverse of x in terms of cos inverse and tan inverse. Okay. So sine inverse of x equal to cos inverse of root of 1 minus x square if x value is 0 less than or x less than or 1, and sine inverse of x equal to minus cos inverse of square root of 1 minus x square if -1 less than or x less than 0, and also sine inverse of x in terms of tan inverse of x by root 1 minus x square. Here condition for x is x belongs to open interval of -1 to 1. Okay. Now let us go to express cos inverse of x in terms of sine. See, just now what did we do? We expressed sine inverse of x. So in terms of cos inverse of root of 1 minus x square you got if x value is 0 less than or x less than or 1, and this is equivalent to minus cos inverse of root of 1 minus x square if -1 less than or equal to x less than 0. Now this is equivalent to tan inverse of x by root of 1 minus x square if x belongs to open interval of -1 to 1. Okay. So we have discussed about sine inverse of x equal to these three. Now let us go to express cos inverse of x in terms of sine inverse. So for that what you need to do? Let us take cos inverse of x equal to theta. Okay. Now, so x equal to how much? Cos theta. Hereafter what you have to do? So you have to define this cos theta is equal to x on this right angle triangle. So consider this angle b theta. Now cos theta definition, adjacent by hypotenuse. Now same like previous one, apply the Pythagoras theorem so that you will get AB as root of 1 minus x square. Okay students. Now actually what we people are doing here, we are expressing cos inverse of x in terms of sine. Okay. So right. So in terms of sine, for that what you have to do? Right. Define sine theta. Sine theta is equal to opposite by hypotenuse. So what do you get? Root of 1 minus x square. Now we want here theta because we assumed this value as theta. So here we have to determine theta, but that should be in terms of sine. Okay. So for that I defined here sine theta. So now here I want only theta. So that okay, what you have to do? Transfer sine to the right side so that here you will get sine inverse of root of 1 minus x square. Here also, cos inverse of x domain. Here x will take close interval of -1 to 1, no? So that here theta is equal to this much when x value is 0 to 1. Suppose this x is negative. So you know cos inverse of minus x. X value close interval of here. Actually x value from where to where? Cos inverse of minus 1 to 1 only. So if it is negative, now this can be written as pi minus cos inverse of x. Am I right? Students, so if x is 0 to 1, then cos inverse of x equal this much we will get. Suppose here, whichever is placed here, if it is negative, then this has to be written pi minus cos inverse of x. Okay? So that here, what do you get? Cos inverse of x equal theta you have taken now. So here, theta is equal to what do you get? Pi minus cos inverse of x. But cos inverse of x equal this much you got no? Sin inverse of root of 1 minus x square. Okay students. Okay, when we have to take theta is equal to pi minus sin inverse of root of 1 minus x square, whenever x value is minus 1 to 0. Okay students. Right. Now see. Therefore cos inverse of x is equal to, so we got sin inverse of root of 1 minus x square if x value is 0 to 1. Now this is equivalent to pi minus sin inverse of root of 1 minus x square if, so minus 1 less than or x less than 0. Remember these two formulas. Next, I would like to express this tan inverse of x in terms of sin inverse and cos inverse. Express tan inverse of x in terms of sin inverse and cos inverse. So for that, so let us consider tan inverse of x equal to theta. Now x equal to tan theta. You know the domain of tan inverse of x, set of real numbers, and the range also will be, domain of tan inverse of x. Okay, you know domain of tan inverse of x is R, and a set of range also set of real numbers only, R to R. Okay, right. Right students, now come here, tan inverse of x, domain is set of real numbers, whereas range is open interval of minus 90 to 90. Okay, what is the domain of tan inverse of x? Set of real numbers, and the range will be minus 90 to 90, you know that. Leave it, but what is our aim here? We need to express tan inverse of x in terms of sin inverse and cos inverse. So for that, what did we do? We assumed this one is equal to theta, then x will be tan theta. Now furnish this details on the right angle triangle. Okay, define on this. So what do you get? So tan theta with respect to theta, opposite is x here, nothing is there means 1. Now x 1. Apply the Pythagoras theorem so that you will get AC square root of 1 plus x square. Now define sin theta. Now sin theta is equal to opposite by hypotenuse. So here what do you get? X by root of 1 plus x square. So now theta is equal to sin inverse of x by root of 1 plus x square you will get. Okay, so here if x is positive only. Similarly, okay, cos theta. Now adjacent by hypotenuse, 1 by root of 1 plus x square. Now theta is equal to cos inverse of 1 by root of 1 plus x square. Here also x should be positive. Okay. So tan inverse of x equal to theta you got. Theta how much you got here? Sin inverse of x by root 1 plus x square when x is positive real number. And in terms of cos inverse of 1 by root 1 plus x square if x is positive. Okay. So these are first set formulas of this class. Now let us go to the second set of formulas from this inverse trigonometric functions. I hope you have understood this first set, in which what did I explain? We expressed sin inverse of x in terms of cos inverse and tan inverse. And next cos inverse we expressed in terms of sin inverse. Next we expressed tan inverse in terms of sin and cos. Now let us go to the second set of formulas. Right. See the second set. Sin inverse of x plus cos inverse of x is equal to 90 degrees if x belongs to closed interval of -1 to 1. And next, tan inverse of x plus cos inverse of x is also equivalent to 90 degrees if x belongs to any real number. Next, cosec inverse of x plus sec inverse of x, which is equal to 90 degrees if x belongs to or minus open interval of -1 to 1, or this can be also written as -infinity to -1 closed union 1 to infinity. X belongs to, here also x belongs to. Okay, note down these three formulas. Okay, I explain you proof how the sum of this sin inverse plus cos inverse of x is equal to 90 degrees. Okay, right. Now let us see the proofs of these three. Now see the first one. Now let us take sin inverse of x equal to some alpha. Then x will be sin alpha. Now draw the right angle triangle. Okay. Now define this. Let it be alpha. So x by 1 you will get here. Now opposite by hypotenuse. Adjacent will be root of 1 minus x square you will get. Similarly, consider this is equal to beta. Cos inverse of x equal to beta. Now x equal to cos beta. X equal to cos beta. Now go to the right angle triangle and take here beta and define this cos beta on this right angle triangle. Here adjacent is x, hypotenuse is 1. So opposite will be 1 minus x square. Okay students. Now here after this we have taken alpha, this is beta now. This is alpha, this is beta. Now alpha plus beta. So with respect to this alpha plus beta, define any trigonometric ratio. That is your wish. Okay? Your wish. Shall I define sine? So if you want to define sine, you can, no problem. Now sine alpha plus beta is equal to sine alpha cos beta plus cos alpha sin beta. Now sine alpha means go to this alpha right angle triangle. Okay, sine x by 1, x by 1, and cos beta means go to this beta right angle triangle. So cos beta adjacent by hypotenuse, x by 1 you will get, plus cos alpha. Cos alpha means go to this right angle triangle and define cos, root of 1 minus x square you will get. Similarly, so cos alpha, sin beta. Sin beta means go to this beta rectangle triangle and define sine. So you will get root of 1 minus x square. Now simplify. Simplify this. If you simplify x into x, x square plus this into this, what do you get? Root of, see here, when you take the product of these two, you will get 1 minus x square. Now this x square cancel, 1 is left. So before alpha plus beta, what is there? Sine there. So here sine of alpha plus beta. Now express this one in terms of sine. So you will get sine 90, no? Sine 90. Now both sides sine ratios are there. In such case you can compare these angles. Now alpha plus beta is equal to 90 degrees. Alpha means sine inverse of x. Beta means cos inverse of x. Am I right? Now whose sum, how much have you got? Pi radius by 2. Observe that where x belongs to close interval of minus 1 to 1. Because the domain of the sine inverse of x is close interval of minus 1 to 1. This cos inverse of x domain also close interval of minus 1 to 1. So that the total compound function domain also will be close interval of minus 1 to 1. Whose sum is equal to pi radius by 2. Okay. Similarly, you prove the rest of the remaining two formulas. Tan inverse of x plus cot inverse of x equal to 90 degrees, where x is any real number, and secant inverse of x plus cosec inverse of x is also equal to 90 degrees, where x belongs to minus infinity to minus 1 closed union 1 to infinity. Okay na? So that two formulas proofs also same like this. So you try those two formulas proofs. Okay. Thank you.